Hi, this is Marc Roth, and this is Mathematics for Social Justice. Today we're going to do part 3 of harmonic mean. In a previous video, I talked about a particular example where we had 10 and 40 being two numbers A and B, and the arithmetic mean, which I call M, was 25. And the geometric mean was 20, and the harmonic mean was 16. And we had this relationship that A times B was equal to M times H was equal to G times itself. So in this case, we have 10 times 40 equaling 16 times 25 equals 20 squared. They're all equal to 400. So the question I want to get at is, where does this come from? And I believe it comes from the 3, 4, 5 right triangle. And I will try to show you why. So this example has a partner. Five times 45 has an arithmetic mean of 25 also. And 5 times 45 is 225. And that is equal to 25 times 9. And 225 is equal to 15 squared. So that's another example. And we also get a nice series of equalities. So I'd like to show you where this comes from. I draw a circle, x-axis, y-axis. Pick a point on the semicircle, draw this line, and draw this line. And draw this line. I claim I have 3 similar triangles. I call this one L for little, or actually I'll name it Larry. And this one here is M for Mo, or middle. I'll just call it Mo, but middle sized. And if I put them together, I get something that's colossal jumbo, so I'll call that Curly Joe. So I have Larry, Mo, and the whole thing is Curly Joe. Now I claim these are similar triangles because they have the same 3 angles. So it's not hard to prove. We know from Tolle's theorem that this is a right angle. So Curly Joe has a right angle, but so does Larry, and so does Mo. So Larry and Curly Joe share this angle. So if they have 2 angles the same and they have 3 angles the same, which means they're similar and they have the same basic shape. So Larry, I'll just write it like this. Larry is similar to Curly Joe. Now, Mo and Curly Joe share that angle. So they have 2 angles the same, so they're also having 3 angles the same, and they're similar. Mo is also similar to Curly Joe. And similarity is a equivalence relationship, if you know what that means. So that means Larry and Mo are also similar from transitivity. So we have 3 similar triangles. There's a theorem, actually I forget if it's a theorem or a postulate, that if you have similar triangles, the corresponding parts are in proportion, which means you get equal ratios. So for example, if we're talking about Larry and we're talking about Curly Joe, we can look at their Well, let's just start with Mo, Larry and Mo. We're going to look at the short leg to the long leg here being equal to the short leg to the long leg here. So the short leg of Larry is to the long leg of Larry, as the short leg of Mo is to the long leg of Mo. We can do the same thing with Larry and Curly Joe. We can look at short leg to hypotenuse here, and short leg to hypotenuse here. So the short leg of Larry is to the hypotenuse of Larry, as the short leg of Curly Joe is to the hypotenuse of Curly Joe. And we can do the same thing comparing Mo to Curly Joe. So we'll look at long leg to hypotenuse equal to long leg is to hypotenuse. So the long leg of Mo is to the hypotenuse of Mo, as the long leg of Curly Joe is to the hypotenuse of Curly Joe. In this case, suppose this is 2 and this is 8. So we would go 2 is to something as something is to 8. We'll call this H. So 2 is to H as H is to 8. So we cross multiply, we get H squared equals 16. So H equals 4. So this height is 4. Okay, so now we're going to erase some things. And we're going to draw another line segment. And then one more line segment. And this is a perpendicular. So that's a right angle right there. So I claim this is actually going to be the harmonic mean a harmonic mean. This will be the geometric mean. And this whole length will be the arithmetic mean. So I'm going to have m being the whole length. M is this whole length. And to prove that, I need a new Larry, a new Mo, and a new Curly Joe. So this will be my new Larry. This will be my new Mo. And the whole thing will be my new Curly Joe. Long leg of Mo is to hypotenuse of Mo, as long leg of Curly Joe is the hypotenuse of Curly Joe. So H is to G as G is to M. When I cross multiply, I get my familiar M times H equals G squared. But in this case, we already found out this was 4. So H is to 4 as 4 is to 5. So if I cross multiply, I get 5H equals 16. And divide by 5, that cancels. H equals 3.2. To make that a whole number, I have to times by 5. So basically, this distance was 5. So now I'm going to times by this distance again. So if I times everything by 5, I have 3.2, I have 4, and I have 5. If I times everything by 5, I get 16, 20, and 25. So if you remember, and this is your A, and this is your B. So your A is 2, and your B is 8. So you have 2 and 8. But remember, we times everything by 5, right? So that'll be 2 times 5 will be 10 now. And 8 times 5 will be 40. And we ended up with 16, 20, and 25. So that's where our first example came from, where we had A, B, M, G, and H all being whole numbers. And it came from the 3, 4, 5 right triangle because this was 3, 4, 5. So now we've reoriented this 3, 4, 5 right triangle. It used to be 3 and 4, now it's 4 and 3. But we're going to calculate this. So again, we have a new Larry, a new Mo, and a new Curly Joe. And this is a right angle. So we have long leg of Mo is the hypotenuse of Mo, as long leg of Curly Joe is the hypotenuse of Curly Joe. So H is to G as G is to M. But before doing that, we actually should have found the value of G. So 1 is to G as G is to 9. And when you cross multiply, you get G squared equal 9. So G equals 3. So this is 3. So we can replace these two G's with 3. So H is to 3 as 3 is to M. So when you cross multiply, you get MH equals 9. And we already know M is 5. So we get 5H equals 9. So H equals 9/5, which equals 1.8. So we're going to have 1.8. We're going to have 3. And we're going to have 5. And A is this distance, 1 and 9. And to get everything a whole number, we can times by 5, 5, 5, 5, and 5. So we'll get, replace the 1 with a 5, and replace this with a 9, this with a 15, this with a 25, and this with a 45. So both of these, which I had given to you earlier, came from the 3, 4, 5 right triangle using elementary Euclidean geometry. So many people with knowledge of the harmonic mean know that 1/4 is the harmonic mean of 1/3 and 1/5. So how can we see why that's true? And you can continue with that and say, okay, 1/3 is the harmonic mean of 1/2 and 1/4. Not the arithmetic mean, but the harmonic mean. So how could we see that? We can use the fact that the harmonic mean is homogeneous. So if you have A, B, M, and H, we're going to divide each of these by AB. And when we do that, this formula 2AB over A plus B, and this formula A plus B divided by 2, they're going to be transformed. So we're going to divide by AB. So when you divide this by AB, A divided by AB, the A's cancel and you get 1 over B. So 1 over B goes here. And when you divide this by AB, you'll get 1 over A. When you divide this by AB, you'll get 2 over A plus B, which is the reciprocal of the arithmetic mean. And when you divide this by AB, you get A plus B divided by 2AB. So here you get the reciprocal of the harmonic mean. So if this was 1/5 and this was 1/3, the arithmetic mean of 3 and 5 is 4. So this would be the reciprocal of 4, which would be 1/4. And that basically proves the result. So if you have this being 3 and this being 4, actually 5, I mean, the arithmetic mean would be 4 and the reciprocal would be here. So the reciprocal of the mean of 3 and 4 would be here at the harmonic mean. And we're just moving up because everything's homogeneous. You can always divide by something, and this is still going to be the harmonic mean. This is still going to be the arithmetic mean in the same place on the number line. So that demonstrates that result. Another way to get that result, and a nice do now exercise for students is when they come into class, you can have this on the board. You can have 1/4 and 1/2. And 4 plus 2 is 6, so split this into 6 spaces. And since that number is 2, you go 2 spaces over, and that'll actually be the harmonic mean, and that'll be 1/3. Okay, so one more example. If you have 1/5 and 1/3, since 5 and 3 is 8, split this up into 8 spaces. And then, since that's 3, go over 3 spaces. And that's where you'll find 1/4. And you can, check that, but it'll turn out to be true.